Hello students, in this video I will go through the process of constructing dilations by integer multiples. Let's take a look. Okay, so to start, on a blank sheet of paper, what I want you to do is to draw something relatively similar to what I'm about to put on the paper here. I'm going to place a point P over here, which I'm going to place on the left side of the paper, and then I'm going to place 3 points, which I am going to place right here. So I'm calling this A, this B, and then this C. Okay, so again, this triangle that I formed here, I want you to draw it relatively similar to that size, okay, and place that triangle relatively close to point P. Pause the video, okay, to do this if you need, but I'm going to do it right now, so you can keep on pressing play if you'd like, but if I'm going through it a little too fast, certainly press pause. So I'm connecting the lines, connecting the dots, and this is what I end up with is a triangle ABC. Again, something to that effect. And then what I want to do is I want to dilate this figure, and in the title of the video I set by multiples, by integer multiples. And what that means is, okay, I'm going to be dilating it by factors of 1, 2, 3, 4, 5, 6, you know, to by those amounts. No dilations of 1.5 or, you know, radical 2, only whole numbers here. We can certainly also dilate by negative values, but it will be in the other direction. I want to talk about that in a moment, maybe in this video, or maybe I'll make it in a separate video. So what I'm going to do is, if you recall the theory, when we were dilating something over a coordinate grid, we essentially is duplicating the distance between a vertex to the point of dilation, and we're duplicating that distance by factors of 1, 2, 3, or 4. Okay, so that's what we're going to try and do here. We are going to be applying that theory, okay, into practice on in a different scenario here. So what I'm going to do, I'm going to connect my point A and P together, and I will be extending the line formed by points A and B, A and P. So I drew that line. I made a little error right there, so you try to be careful when you're drawing yours. And I'm going to be connecting the points P and B. And I will do the same, connecting points P and C. And what I'm going to do is I'm going to take my compass, place my pin on P, place my lead on A, and it looks like it's just right about right there. Keeping this compass setting, I'm going to pick it up, I'm going to place my pin on A, and I'm going to make a mark on the line PA. Alright, I'm going to repeat this for all 3 points. I'm going to place my pin on P again, open up the compass so that the lead hits B, and it looks like it's just right there. Pick up my compass, place my pin on B, and make a mark just like that. Place my pin on P again. Place my lead on C. And pick up the compass, place my pin on C, and make a mark on the line and I'm going to label all these different intersections here. This is going to be my A prime, this is B prime, and this is going to be my C prime. And what I'm going to do next is I'm going to be connecting the points of intersections. So it's going to look something to this effect. And I connect. And I connect. So this is going to be so this triangle now, A prime, B prime, C prime, this is a dilation by a factor of 2. Now I can actually repeat this, okay, and do this one more time, however many times I want, right? So if I wanted to, let's say, find out the dilation by a factor of 3, okay, I can actually continue this. I'm going to extend this line, extend the lines that I've made. Extend the lines that I've made. And essentially just repeat this process by measuring the distance between P and A, B and P and B, and P and C. So I want to do this one more time. So if I measure this distance again, this is PC right now. If I do this one more time over here, so this would be my C double prime. And if I do the same thing with A and B, repeat this one more time with A and B, so I place my A over here, like so. This is my A prime, A double prime. And one last time. Oh, looks like I need to extend that line a little further, which I'm going to do right now. So this is going to be my B double prime. So I will now connect B and C together. I will connect A and C together. And if for some reason your 6-inch ruler, 6-inch straight edge doesn't really quite reach, then I would recommend, getting a another ruler or another straight edge, okay, where it will reach. Because sometimes when you're dilating, things will get big, and they will get big fast. Which is why on the Regents, they typically don't ask you to dilate anything any more than 2. No more than, usually it's just 2. So anyway, there you have it. So this is the original, dilation of 2, dilation of 3. If we wanted to go the other way around and dilate this by a factor of, let's say, 1/2, okay, then we would have to actually, find the midpoints of each of these lines and thereby creating a perpendicular bisector. But I'm not going to get into that, okay? We're just going to go into integer multiples here, so factors of 1, 2, 3, 4, and 5. Okay, if you wanted to go in the other direction, let's say negative integers, okay, by factors of dilation by factors of -1, -2, -3, you would actually extend the lines in the other direction over here and pretty much just repeat the process. Okay, but there you have it.